This is the Folland Gnat, and if I tried to sit in that cockpit there, my knees would be touching my ears. But this tiny little aircraft has an engine in the back of it that ended up being the ancestor of one of the biggest, most powerful engines in a single engine aircraft. But today we're going to look at why being small was actually the strength of this aircraft. Back in the 1950s, in both the private and the public sector, it was becoming increasingly clear that as the new generation of jet fighters were becoming more complex and bigger, that should there be an all-out war, there wasn't a cat's chance in hell that they would be able to mass produce in anything like the quantities some of the Second World War aircraft were churned out. Fortunately, one of the clever cookies pondering this problem was the aircraft designer Teddy Petter. Now, Teddy deserves a video all of his own. For one thing, he designed this, the Canberra, and this, the English Electric Lightning, and he designed the Lysander, one of my all-time favourite aircraft, and the Whirlwind, which was an impressive aircraft all in its own. It's fair to say that Teddy Petter had a pretty good idea what he was doing when it came to designing aircraft. By 1950, Teddy had joined Folland and he was meeting with the Air Ministry to discuss their mutual concerns about not having an easy to make, mass-producible fighter aircraft that they could send out to go and chase down Soviet bombers. And this isn't off in the distance, by the way. It really is that small. I can reach out and, well, I could touch it, but I'm not going to because you shouldn't. But it really is just that small. Anyway, this being the British government, obviously everything went without a hitch and completely smooth. Obviously not. The Ministry of Own Goals decided that they wanted to go in a different direction and abandoned the idea in the project. Meanwhile, Teddy decided to use some of the resources from the company, from Folland, to go ahead and build it as a private venture and to make a testbed and to make a demonstrator to prove he was right. Now at this point we're going to take a slight detour and talk about this. Not this board, they're having a model show, so things are all kind of moved around. We're going to talk about this, the Orpheus engine that's hidden behind it. So I'm just going to hold the camera over the top so you can have a quick look. One of the biggest stumbling blocks for Teddy was that there simply wasn't a powerful enough engine that was small enough. He knew that it was possible, but he was an aircraft designer, so he had to rely on a third party to provide an engine that could meet his needs. Armstrong Siddeley and Rolls-Royce had failed to provide the solution, but Bristol absolutely nailed it with this, the Orpheus. What makes the Orpheus so ideal is the unique design of its turbine shaft. This, on the other hand, is a Spey engine, and it's an axial flow turbine. And as you can see by the size of it, it's almost the entire size of a Gnat aircraft. But this is a more typical example, and this was inside the British F4 Phantom. But anyway, this is an axial flow engine. So let's do a quick 101 on how a jet engine works. On the inside of an axial turbine engine, you have a process that breaks down into 4 parts known as suck, squeeze, bang, blow. The compressor at the front takes care of the suck and squeeze part, compressing atmospheric air. The combustion chambers take care of the bang and heats up that air and adds a little bit of mass from the fuel and a whole lot of pressure. And the turbine and exhaust are where all that mass and pressure escapes and sends a chunk of metal across the sky at a hell of a rate of knots. This makes for a very long spindle, and that long spindle has to cope with an awful lot of force going on its very small cross-sectional area. When it's spinning really fast and hot, there's a risk of any imbalance or warping turning it into a steel skipping rope. To stop that, there's a bearing at the front, a bearing in the middle, and a bearing at the back. And this is where the Orpheus has a trick up its sleeve. Instead of a thin solid spindle, the Orpheus uses a barrel spindle. It's the same weight of metal, but in a hollow barrel. And this gives it much more ability to cope with torsion without a weight increase. But this also gives it the ability to skip that central bearing, which makes it overall shorter and lighter for the same output. Power and weight are the most important figures when it comes to engines. More power and less weight means more energy available to do the work. And this little Orpheus was the power plant Teddy needed for his aircraft. But just before we go back to the Gnat, a quick side note on the Orpheus. It was the power-to-weight design of this little engine that went on to develop into an absolute monster. And it's in the heart of this thing, the Harrier jump jet. And the engine that's in this is called the Pegasus, and it is a development of the Orpheus. And the reason the Orpheus worked so well scaled up into this was that you had to have an engine with an incredible amount of power that was as light as possible and could fit into as small a space as possible. Because the Harrier jump jet has to work against gravity using nothing but the thrust of its engines and no aerodynamic assistance. So it produces the most power to weight for any single engine aircraft. It's not the fastest single engine aircraft by any means, but the amount of power that comes out of that engine is incredible. And that's why the Orpheus was such a good choice of it, because the Orpheus produces so much power for the amount of pounds that it weighs, and that's how you get the Pegasus. So with the usual demonstration of clueless short-sightedness that the UK government showed, the need for a small fighter was shelved, but Teddy pressed on anyway and built something called the Midge, which was a smaller version of the Gnat, but it was essentially the same aircraft. It just used a smaller engine because the Orpheus wasn't ready yet, so that's why there was a Midge before there was a Gnat. But for all intents and purposes, same aircraft development. Teddy might have been a genius with machines, but he was terrible with humans. He had a rigid lack of compromise that made for excellent aircraft sometimes, but also made for inflexibility when it came to the more esoteric concerns. NATO wanted a small fighter, but they also wanted one that could be used on rough, unprepared runways in the event of airfields being turned into glass by cranky commies. Teddy didn't care. Modifying the landing gear of the Gnat to suit this need would mean a minor change in the airflow around the wheelbase, and he was having none of it. And with that, the Gnat lost its future as a frontline European aircraft. Though not entirely, there was one insane plan involving the Gnat in Europe, but we'll get back to that in a bit. To be fair to Teddy though, he wasn't just being obstinate, he actually had good reason to argue about the landing gear. The landing gear on this aircraft is more than just a stick that you put the wheel on the end of. In Teddy's efforts to make this light and cheap, what he'd actually done was designed it so that the landing gear could be partially deployed and used as an air brake. So it doubled in two functions. It was the landing gear, but it was also an air brake. But there is a little bit of irony to that. Teddy, the guy who designed one of the ultimate aircraft for landing on rough ground, the Lysander, ended up making this the one hill he chose to die on. Almost to add insult to injury, the trainer version developed by Folland after Teddy's time had the required landing gear and proved that there was negligible airflow disruption from the landing gear being slightly bulged. And this is where Teddy and the Gnat parted ways, between arguments with India, one of their largest customers, and the Europeans not being interested because of the landing gear issues. Teddy decided to call it quits on the aviation industry in general and went off to join a religious commune where he spent the rest of his years. Not a joke, he really did that. So there's that. Meanwhile, the Gnat had been adopted by the Indian Air Force, who built it locally under licence, and it was developed as a two-seater trainer version for the RAF, which they could only do by removing the internal fuel tanks and designing new wings to house the fuel instead, because it's not exactly roomy in there. Beyond that, there was talk about doing multiple other versions. There was talk about a swing wing version that was capable of Mach 2, but none of it actually ever got beyond the paper phase and never got turned into an airframe or even a demonstrator. So, how did the Gnat fare in actual service? Well, if you ask the Indian Air Force, rather well. If used with the right tactics and in the right situations, it became a massive pain in the butt for the Pakistani Air Force in their Canadair Sabres. I'm aware this is the wrong type of Sabre, but you use what you've got. In India, it was known as the Sabre Slayer, and as a result, being really small and light made it hard to see at low level, and it could beat a Sabre in the vertical. In the RAF, it was exclusively used as a trainer in the two-seater T1 variation. It was used as the first step on the way to specialising as a fast jet pilot. Most famously though, it was used by the Red Arrow display team, a job it did for 14 years before being transferred over to the Hawker Siddeley Hawks in 1979, the airframe that's still in use today. So despite not being a frontline aircraft, the Gnat did see a fairly good chunk of service in Europe in the end. As much as it is a great aircraft, and it did stand up fairly well against some of the competition, it didn't actually see very widespread adoption, and it definitely wasn't without its flaws. For one, the downside of this compact little Orpheus was that it would misalign itself when it was used and cause bent thrust. When the engine heats up and starts working under load, the mounts can warp and the exhaust goes off axis and causes yaw. It had control issues due to its complex control systems and fuel system. For the Finnish Air Force, it proved to be an absolute nightmare, with huge numbers of maintenance hours for every single flight hour, and the obvious issue, tall pilots struggling to fit in it. In fact, if you were tall, half of the console wasn't even visible because it was hidden behind your knees, so in the end, as brilliant as it was when it worked, it just simply wasn't able to meet the needs of most air forces of the time. So about that insane job that ties our diminutive Gnat into one of the biggest aircraft the RAF flew at the time, which was the Avro Vulcan. Yeah, let's get into that. Back in the 50s, before strategic nuclear bombers were made obsolete by missiles, the issue facing a bomber like the Vulcan was that in order to get to the target, it would have to fly through contested airspace. So the plan, such as it was, involved attaching 3 Gnats to the underside of a Vulcan and turning it into a support aircraft. A conventionally armed Vulcan and a carrier Vulcan would fly into enemy airspace, and when the inevitable angry Reds came to politely ask them to leave, the Gnats would detach and then go take on the MiGs. Fortunately for the Gnat pilots, this plan was scrapped, partly because standoff launch missiles became a thing, and partly because as Madcap Cold War plans go, this was a particularly madcap one. If you'd like to hear more stories about Cold War aircraft, then watch one of these 2 pinned videos, and a like and a subscribe on your way would be appreciated.